Hello students, welcome to Learner's Planet, problem solving session 3 of metals and non-metals. In the previous session we discussed questions related to the reactivity series and also the chemical properties of metals. In this session also we will be dealing with few more properties of metals. Now taking up our first question, it is related to your chemical reactivity series of metals, and it reads as: arrange magnesium, aluminium, zinc and iron in the decreasing order of their reactivity with dilute acids. Now till now I have written the full complete reactivity series twice, thrice or more than that. Now you just decide which is more reactive in this. The more reactive metal here is, of course, magnesium. We have to arrange them in their decreasing order. So our more reactive metal here is magnesium. So this is more reactive than what? Aluminium. I hope you must have memorized the reactivity series. If not, do it as soon as possible. And your aluminium is more reactive than zinc. Zinc is more reactive than iron. So I think in the question itself it has been arranged. Now how we will measure the reactivity with dilute acids? It depends on how fast the hydrogen bubbles are formed. So it will be the fastest with magnesium and the slowest with iron. Why it forms hydrogen? Because hydrogen bubbles, metals form what type of ions? Positive ions, giving out electrons. These electrons reduce H plus ions of acids, giving what? Hydrogen gas bubbles. So depending on how fast these hydrogen bubbles are formed, the reactivity is decided, and also on the basis of the reactivity series. So if you have memorized the reactivity series, there will be no problem in solving such type of questions, whether it's reactivity with acids or the reactivity with water. Now let's take up our next question here. It is: what are the products formed when iron reacts with cold dilute hydrochloric acid? Now what is iron, children? Iron is a metal. I hope you would have guessed the products here. So it is a metal. When metal reacts with dilute acids, what are the products formed? The respective metal salts, and what else is formed? And of course the hydrogen gas is evolved. So what metal salt will be formed here? The metal salt would be ferrous chloride, FeCl2. And what will be the byproduct here? It would be H2 gas. So ferrous chloride plus of hydrogen gas is evolved. So metals react with acids forming their respective salts and hydrogen gas. This is ferrous chloride, or I can write it as iron 2 chloride. Now our next question, moving to the next question, it is the same type of a question, but our metal is different. Metal is what? What are the products formed when calcium reacts with cold dilute hydrochloric acid? So our metal is different, that's it. So what will happen? Calcium is more reactive than iron. The hydrogen gas bubbles formed will be faster than that of iron. So there is calcium plus twice of HCl, aqueous, and what will be the products formed? This is a very easy question. I know you would have guessed the products till now. It would be CaCl2 plus of H2 gas. So whenever a metal reacts with dilute acid, except nitric acid, hydrogen gas is evolved and metal salt is formed. I'm clearly telling you, you have to exclude nitric acid from this. You have to keep only hydrochloric and sulfuric acid. Carbonic acid is one thing, phosphoric acid you can take, but nitric acid, With nitric acid, hydrogen gas is not evolved. Now let's take up our next question. Yeah, it is the rate of formation of hydrogen gas bubbles on the reaction of given metals with dilute acids decreases in the order. How it will decrease? Magnesium is the most reactive metal. After magnesium, what will come? It should be copper or zinc or iron. What would be the thing? It should be zinc. Zinc is more reactive than iron. Then what will be the thing? Iron is again more reactive than copper. So the rate of formation of hydrogen gas bubbles will be maximum in magnesium and it would be least, that is minimum, in copper. So these are all, students, based on the reactivity series. Once you memorize that reactivity series, you'll have no problem in solving such questions. Now let's take up our next question here. It is, what are the products formed in the given reaction? There is a metal, that is silver, and it is reacting with sulfuric acid. Now just tell me, what will be the reaction? We know that silver is the least reactive metal. Your least reactive is, I think, gold. We can write it here, it is a less reactive metal. So silver is a less reactive metal. It will react with hot concentrated sulfuric acid, but it will give no reaction with dilute acids. And of course, silver is present where? Silver in the reactivity series is present below hydrogen. So this silver cannot replace hydrogen from acids. So what will be the answer of this question? It should be no reaction. Likewise, your copper also. Copper also cannot displace hydrogen from acid. Gold is out of question. Even mercury cannot displace hydrogen from acids. Now let's take up the next question. Which gas is evolved when metals react with dilute nitric acid? As I have already told you that metals react when dilute with nitric acid, as it is a very strong oxidizing agent. What it does? It oxidizes hydrogen gas evolved. It oxidizes the hydrogen gas evolved to what? To water. And HNO3 itself gets reduced to what? To either N2O or NO or NO2. So here you should remember one thing, that with dilute nitric acid, let's take up example of metal, any metal, that is copper or lead or tin, whatever it is. If I'm taking, say, copper, if I'm treating it with dilute nitric acid, what would be the products formed? The products formed would be copper nitrate, that is CuNO3 whole twice, plus of NO. Why? Because this is dilute, plus of H2. And if it is a concentrated nitric acid, HNO3 concentrated, then what happens, children? That once this NO is formed, concentrated nitric acid further gets reduced to NO2. It will form NO2. With concentrated nitric acid, what are the products formed? Again, copper nitrate, CuNO3 whole twice, plus NO2, plus H2. So remember these two things, that with dilute nitric acid, the gas evolved is NO, and with concentrated nitric acid, it is NO2. Zinc with very dilute nitric acid evolves N2O also. Let's take up our next question here. Yeah, it is hydrogen is a non-metal, but why it has been assigned a place in the reactivity series of metals? Do you remember we have got hydrogen in between? That is, I'll write few metals, that is zinc, then is your iron, then is your tin, lead, then is your hydrogen. Then again few metals, copper, mercury, silver and gold. But hydrogen is what? Hydrogen is a non-metal. Then why it is placed with metals? This is because the only reason for this is that hydrogen, the answer for this question, if it comes in your board exams, the answer for this question would be hydrogen forms positive ion by losing electrons. Just like metals. So, like metals. That is why it has been assigned a place in a metal reactivity series. I hope this is clear to you. Now let's take up our next question here. It is, name the metal which has been placed at the top of the reactivity series. Quickly, just try to remember which is the metal which is on the top of the reactivity series. It is potassium. And our second question is, name the metal which has been placed at the bottom of the reactivity series. So what is it? It is gold. So this is what? This is most reactive. Most reactive metal. And this is what, children? This is least reactive metal. So this is a question related to our reactivity series. Now let's move to our next question. Again, it is related to the reactivities. Arrange the following metals in the order of their decreasing chemical reactivities. I hope you can arrange it very easily. Let's arrange which is more reactive, magnesium or calcium. It is calcium. It is more reactive. Then which metal will come? Magnesium. Again we have got sodium also here. So sodium is more reactive than calcium. Sodium is more reactive than calcium. Calcium is more reactive than magnesium. Then what all metals we have? We have got iron and zinc, copper and lead. So copper is below hydrogen. So it should be least reactive. We can place it at the last. Then what we have got? We have got iron, zinc and lead. So now which is more reactive? Zinc is more reactive than iron. And iron is again more reactive than lead. And the last one is copper. Because copper is below hydrogen in the reactivity series. Now if I ask you to arrange gold, silver, copper and mercury, where they lie? They all lie below hydrogen. Below hydrogen in the reactivity series. So, which is most reactive of these? It is of course copper. Then is mercury. Then is silver. And then is gold. So for solving all these questions, these are very important. This type of questions you'll get in your Olympiads or even in your board exams. So it is my advice that you should memorize the reactivity series. That's it. That reactivity series is very, very important in this topic, that is metals and non-metals. That is why there are so many questions related to it. Now let's take up our next question. Which metal is the best conductor of electricity? Which is it? Is it silver or copper? It is silver. Silver is the best conductor of electricity. But then why we are using copper? This is because if we are making silver wires, it will become too expensive. So we are not using silver for making wires. We are making because we are using copper. Now name the metal which is soft. It can be either sodium or potassium. Anything can be. Both of them are soft. Both of them you can cut with a knife. Both the metals can be cut with a knife. So they are soft. A metal which has low melting point, that is 30 degrees centigrade. Which is it? It is gallium. And your another metal, that is cesium, has a melting point of 28 degrees centigrade. So these two melting points you need to remember. And next question here is a metal which starts melting in hand. Now see children, both are having 30 degree and 28 degree temperature. So both of them can start melting in our hand, get melted in our hand. So what can be our answer? It should be gallium or cesium. Both of them can be the right answer. So these are one-word questions. This you can get in your board exams. So do remember this. I think you should remember the exceptions. Which is a non-metal, which is a best conductor of electricity, or which metal is soft, or which non-metal is hard, and all those things. And let's take up our next question here. It is the reaction of metal X with Fe2O3. What is Fe2O3, children? Fe2O3 is ferric oxide, is highly exothermic and is used to join railway tracks. Identify the metal X. What is it? It is aluminium. I have told you this in metallurgy, that there are oxides like chromium, like manganese, which are reduced by aluminium, and that reaction is highly exothermic. So what is that X? X is aluminium. Now write the chemical equation for its reaction with Fe2O3. Now aluminium reacts with iron oxide, and what is it forming? It is forming Al2O3, that is aluminium oxide and twice of Fe plus heat. Now because of this heat, your iron is in the molten state. So this reaction is highly exothermic, and here we are getting iron in the molten state. What does this mean? That this molten iron is poured on the broken railway tracks and it is left to solidify. So this metal is aluminium and is used for the reduction of chromium oxides or manganese oxides or iron oxides. Now let's take up our next question here. Complete the following chemical equation. Now in this case, what is magnesium? Magnesium is a metal. Where it is present? It is present above hydrogen in the reactivity series. So what it will do? It will release hydrogen gas. So what will be the products formed here in the reaction A? That is magnesium solid plus H2SO4 aqueous, and what would be the products? It would be a salt, that is magnesium sulfate MgSO4, plus which gas would be evolved? So when metals react with acids, that is dilute acids, what they form is they are forming their respective salts and hydrogen gases evolve. I am talking of those metals which are present above hydrogen in the reactivity series and not below hydrogen. The metals which are present below hydrogen in the reactivity series, do not release hydrogen gas because they are not so reactive. For example, our next question, it is copper solid plus HCl aqueous. So what will be the answer of this question? The answer of this question would be no reaction. Why? Because copper is very less reactive, and where this copper is present, this is present below hydrogen in the reactivity series. So what it will do, it cannot release electrons or give electrons to hydrogen ions and reduce it to form hydrogen gas. Or if reason is asked, you can also say that copper is present below hydrogen in the reactivity series. Copper is present or placed below hydrogen in the reactivity series in the reactivity series. So it cannot release hydrogen gas from acids. Or you can also write it is very less reactive, so it cannot release hydrogen gas from acids. Now moving to our next question, children. It is identify the most reactive and the least reactive metals from the given reactions. Copper sulfate plus iron gives iron sulfate plus copper. So which is more reactive? Iron is displacing copper from its salt solution. So of course iron is more reactive. Okay. So what will be the answer of this? Iron, that is Fe, is more reactive. Why? Because it is displacing copper from its salt solution, and copper is less reactive. Now in the next question, it is iron sulfate or ferrous sulfate plus zinc gives zinc sulfate plus iron. So which is displacing what? Zinc is displacing iron from its salt solution. So which is more reactive? Zinc is more reactive than iron. So iron here is less reactive and zinc is more reactive. So if such questions are given, it becomes easy if the reactions are given. You have to just point out which element is replacing the other element from its salt solution. The one which is displacing other element from its salt solution is more reactive. Now moving to our next question. Magnesium hydroxide turns litmus solution. What is magnesium hydroxide? I hope after discussing so many questions, you can solve these very easily. Magnesium hydroxide is basic. So bases turn the litmus solution red or blue. Base will turn the red litmus solution to blue. Now your zinc oxide reacts with sodium hydroxide, forming zinc oxide, ZNO, will react with sodium hydroxide, NaOH, and it will form what? What will be the product form? The product form would be sodium zincate, that is NaZnO2. So the product form would be sodium zincate, that is Na2 ZnO2 aqueous, that is, it is sodium zincate. And what will be the next byproduct? It would be water. Again, your zinc oxide is what? It is an amphoteric oxide. It reacts with a base, giving salt and water. So what it depicts? This reaction depicts the acidic nature. And your zinc oxide reacts with HCl and it forms zinc chloride. What is zinc chloride? It is a salt, ZnCl2 plus of H2O liquid. So what it depicts? It tells us the basic nature. So our zinc oxide is an amphoteric oxide. Now taking up our next question, so the answer to this question would be zinc oxide reacts with sodium hydroxide forming sodium zincate and water. Iron is dash reactive than zinc. Is it more reactive than zinc or it is less reactive than zinc? You must be knowing the reactivity series. So which is more reactive here? Zinc is more reactive than iron. So what would be our answer? Iron is less reactive because zinc is present above in the reactivity series. Now the next question here is magnesium reacts with steam forming. So I have told you children that metals react with steam and they form what? They form their respective oxides, MgO, and hydrogen gases released. So metals react with water forming their respective oxides, whereas metals react with steam forming their respective oxides. Right? With water they will form hydroxides and with steam they will form oxides. So these are all the questions related to chemical properties of metals. I hope you have understood all the aspects of properties of metals. In the next session, we will be discussing questions related to the properties of non-metals. So thank you children for your patience. We will be meeting in the next problem session